Welcome back to Ask Why, where we take engineering challenges and break it down Barney style. Today we're going to talk about ceramic capacitors for high reliability applications. When you really start thinking about satellites, fighter jets, some of those systems really can't afford even a millisecond of downtime. So that's why high reliability ceramic capacitors are designed and tested differently to meet these tough demands. So when you start looking at defense, aerospace, and mission critical electronics, that's where high reliability components really become a very important factor. So with me here today, we have Jake Michaels, product manager for ceramics and MLCCs. And we're going to dive into what high reliability really means for those types of ceramic capacitors. So let's start at the foundation. Jake, so why are ceramic capacitors such key technologies in high reliability applications?
So really, to kind of kick that off, to answer this question, we need to start a little bit of a history lesson. When we first invented the capacitor, we put them, they were basically a mason jar with a saltwater brine of some kind and some metal electrodes, and they were in glass. And that's how we started this whole journey. Well, those are fragile, they dry out, they have a liquid inside of them, all sorts of problems arise. So right about when we started that, and that was pre-1900. Past that point, we started having World War I, World War II. We had all these different issues going on in the world, and the Navy specifically needed ways to communicate across the oceans. So they started coming up and putting money and funding into researching different capacitor technologies that can handle harsher environments. And they came out with two, pretty much. Tantalum, which is one of our other projects here at YAGEO Group, and ceramics, which is the group that I'm in. And so the useful thing about ceramics is that they are relatively stable, so they're a ceramic material. They're very robust that way. They can handle, if you're looking at class 1, they can handle extreme thermal temperatures compared to other technologies, and they can sit on a shelf longer. So that's how this kind of started. For high reliability specifically, once we started focusing on that as a trend, we used very conservative designs that had limited voltage and capacitance ranges, but they had lots of history behind them. They had lots of data telling us this part will work every time at a given condition.
So what reliability levels and standards exist for the ceramic capacitors, especially when we start looking at defense and aerospace?
So if you look at defense and aerospace, there are two what are called mil specs or mil prefs that define the ceramic materials definitions. The first is mil pref 123, and the other one is mil 52535. The 52535 is the newest one. It allows for base metal electrodes. So there are two different kinds of ceramic capacitors when you break them in. There's precious metal electrodes that have expensive palladiums and different metals in the inner electrode layers, and then there's base metal electrodes, which were made by a nickel alloy. And so it's cheaper to move into this base metal electrodes, and so now as we've gotten reliability data on base metal electrode capacitors, the military has come out with a new spec that allows us to use those in some applications.
So now when we started this conversation, you said, can I include a bathtub in this conversation? And it's like, well, we got the bathtub on the screen, so what can you tell us about that bathtub?
So the whole point of the bathtub curve is it shows the lifetime of a capacitor. And so in the beginning, you have a lot of infant mortalities. You have this drop where as soon as you make a batch of parts, a certain number of them will always fail. And you pull those out right away, it's very clear that those are broken. And then you start the journey of the life of the capacitor, and it goes along and goes along. And sometimes if there's any interlayer issues or something that's you can't see visually or test, it'll fail somewhere in that. But those happen very, very low. They're not very common. And then you get to the end of the life of the capacitor where almost every one of them fails, and at some point they all will fail. And so the point of the bathtub curve, when you look at high reliability, is we want to reduce the amount of lifetime issues. So we want to lower the bottom of the tub, and we want to push out the edges. We want to reduce the amount of infant mortalities, but we also want to push and make the capacitors last longer so that the end of life is further out.
Right, that makes a lot of sense. So now, of course, when we start talking about reliability, with high reliability comes high responsibility. So how do we actually verify that ceramic capacitors meet these demanding requirements?
So first thing first, we electrically test 100% of the batch. So we test for capacitance, we test for DF, we test for insulation resistance. We run it through all the electrical tests that we can before the batch leaves the plant. Then we do temperature cycling and burn-in and different accelerated life testings from a sample of that batch so that we know, okay, this batch, there's an issue because this one didn't pass burnout. So we pull that batch aside and we look at it. Then we do what's called a destructive analysis, a DPA. So we take another sample from that batch and we take the capacitor and we cut it in half and polish it and then put it under a microscope and look at the layers and make sure that we can't see any latent issues. And then finally, we do lot traceability. So we make sure that we've traced and followed the whole pedigree of the material so that if we notice any issue in the beginning stage, we can pull that material out and use the correct material for the production of that part. So with the combination of all those things, we can reduce the number of infant mortalities, reduce the number of lifetime mortalities, and hopefully push out the lifetime of the part. That's the goal.
So now I know, of course, that is one of those questions that comes up quite often. Can I just take a commercial product and add some additional testing from that? But I think from what you're telling me is really that high reliability ceramics are completely built different from the start. So what exactly makes them different in practice?
So the first thing is they use a very conservative design. We take a design that we know is effective. We take a design that we know has seen lots of use and it's very reliable. So the first thing is you won't be able to get some of the values from the commercial catalog that you'll be able to get in the high reliability catalog. We also do all of that lot traceability stuff. So all of those materials are very carefully picked out and vetted and monitored. And so by doing that, we're even more heavily controlling what's going on inside that capacitor. And then, of course, we do all the tests. So it's a combination of all those things that makes a part high reliability.
So where do high reliability ceramics really show up? What applications do we have? What should engineers really keep in mind when they start designing for high reliability?
So high reliability really means different things to different people. If you work in the commercial space and you build radios, you can use commercial parts readily available pretty much everywhere. But if you go to build that radio and put it in a car, all of a sudden you bumped up to automotive grade, which has another set of requirements and another set of tests and a little bit narrower portfolio, right? Then you move up the chain a little bit further and you go to COTS, which are commercial off the shelf. Those are another grade above that. You can take a step further and go to HRA, which is high reliability, and then one more step further than that and you're actually in military. Once you get to the military, there's an even further step where you can do, okay, I want space grade that is for like manned space flight. And so in those cases, those are even more conservative designs. And so as you move up this chain of different grades, of course, all of this testing has a price. So the cost goes up, but also the amount of capacitance in the catalog shrinks. So both of those things happen as you move up the chain of high reliability.
So especially when the engineers design those types of components, and you really have to ask yourself the question of what my application is, how it actually fits into those applications. Obviously, a car is going to have different reliability requirements than a military vehicle would be,
right.
Or a commercial jet is going to have different reliability grades than a fighter jet. You know, of course, there's going to be some different challenges that those types of components will face. And so that's why we really have all these different types of grades available. And so with those ceramic capacitors, we really have a lot of additional choices for high reliability applications. So if you have to give one last piece of advice to any of the design engineers considering using high reliability components for their application, what would that be?
It would be to very much understand what grade you need to be designing your product at. So oftentimes, especially in the military space, your supervisors are going to know what quality you need to be building at. You're building a space manned flight mission, you need to be using the space manned flight mission quality. But if you're in automotive, maybe that's not super clear. Maybe your design is near a really hot spot in the vehicle, and you want something with a little more reliability to it. And so you can actually get maybe a COTS product instead. And so really you need to understand what you're designing, how long you need it to work in that condition, and what conditions it's going to be adhered to. How hot is it going to get? What voltage? You really need to understand the limitations of your design.
Well, from harsh environments like space or the desert, we got high reliability ceramic capacitors available to you on our website, yageogroup.com. Go check it out, see what's available to you so that your application can also meet those mission critical requirements and not fail when it matters. With that, I want to thank everybody for joining us. Thank you, Jake, for being on the call again. And with that, just keep on asking why.